The function f is defined as f of x equals x cubed plus 3x squared minus 9x plus 5, where x is an element of or, so x is an element of the real number set. Part A, find the coordinates of the point where the graph of f cuts the y-axis. So where does this function cut the y-axis? Verify that the graph of f cuts the x-axis at x equals minus 5. Part B, find the coordinates of the local maximum turning point and of the local minimum turning point of f. Part C, hence, sketch the graph of the function f on the axis below. This is our x-axis, this is our y-axis, and we need to draw our function on this graph. Part A, find the coordinates of the point where the graph of f cuts the y-axis. So this is our function, f of x equals x cubed plus 3x squared minus 9x plus 5. And the constant at the end, the plus 5, this is known as our y-intercept. So this is where our graph cuts the y-axis. So if we substitute 0 in place of each of our x values, we'll end up getting 5. So we get 0 cubed plus 3 times 0 squared minus 9 times 0 plus 5. That'll give us 0 plus 0 plus 0 plus 5. So we end up getting y is equal to 5. So when we sub in x to be 0, we end up getting a y value of 5. And the point where f cuts the y-axis is going to be 0, 5. So an x value of 0, a y value of 5. Part 2. Verify that the graph of f cuts the x-axis at x equals minus 5. So what we have to do is let x equal minus 5 and substitute it into our function f of x. So we swap each x value for minus 5 with brackets around it. So we get minus 5 cubed plus 3 times minus 5 squared minus 9 times minus 5 plus 5, and this ends up giving us 0. So minus 5, 0 is the point where the graph cuts the x-axis. Find the coordinates of the local maximum turning point and of the local minimum turning point of f. So when we hear maximum turning point or minimum turning point, or maximize or minimize, we want to think differentiate. So there's 3 steps involved. Step 1, we're going to differentiate, equal to 0 and solve. Step 2, we're going to differentiate again and substitute the x values. And step 3, we're going to substitute x values into the original equation. So step 1, differentiate. So our function is x cubed plus 3x squared minus 9x plus 5. So to differentiate, we bring down the power in front and we reduce the power by 1. So to differentiate x cubed, the 3 comes down in front to give us 3x, and we reduce the power by 1. 3 minus 1 is 2. So the derivative of x cubed is 3x squared. To differentiate 3x squared, we bring down the power in front, so it's going to be 2 multiplied by 3, which is 6x, and we reduce the power by 1. 2 take away 1 is 1, and x to the power 1 is just x, so we get 6x. To differentiate minus 9x, well, we don't have a power stuck onto the x, we can just cross off the x. So the derivative of minus 9x is just going to be minus 9. And to differentiate a constant, well, it doesn't have an x value, so we cannot differentiate it. So we just cancel that out. So the derivative of x cubed plus 3x squared minus 9x plus 5 is going to be 3x squared plus 6x minus 9. So we differentiated, now we have to let it equal 0 and we have to solve. So before we're going to do that, we're going to realize that we have a quadratic and we can simplify it by dividing across by 3. So 3x squared divided by 3 is x squared, 6x divided by 3 is 2x, minus 9 divided by 3 is minus 3. So now we're going to let our quadratic equal to 0 and we're going to solve. Now to solve our quadratic, we can use our quadratic formula or minus b formula, or we can factorize and solve. So the quickest thing to do would be to factorize and solve, but it's up to you which method you want to use. So we have an x squared, so we know we're going to have an x in the front of both brackets. This is a minus, which tells us that the signs inside the brackets will be different. This is 3, which tells us that we can only use 3 and 1 because 3 is a prime number, so it only has one factor pair, 3 by 1. And we need to end up with plus 2. So plus 3 minus 1 gives us plus 2. So we get x plus 3 in one bracket and x minus 1 in the other bracket. We let each bracket equal 0. So if x plus 3 equals 0, then x is equal to minus 3. If x minus 1 is equal to 0, then x is equal to 1. So that's step 1 done. Step 2, differentiate again and substitute in our x values. So we have to get the second derivative, and if our first derivative was 3x squared plus 6x minus 9, then our second derivative will be 6x plus 6. So we bring the power down in front, the 2 comes in front of the 3, and 2 multiplied by 3 is 6. And then reduce the power by 1, 2 take away 1 is 1, and x to the power 1 is just x. We get 6x for the derivative of 3x squared. To differentiate 6x, we just literally cross off the x and bring down the 6. And to differentiate minus 9, well, it's a constant, so it can't be differentiated, so we just cancel it out. So the derivative of 3x squared plus 6x minus 9 is 6x plus 6. So this is the second derivative of our original function. So we've differentiated twice. So step 2 said differentiate again, which we did, and substitute in the x values. So we need to sub in minus 3 and 1. So swapping the x for minus 3, we get 6 multiplied by minus 3 plus 6, which gives us minus 12. And then subbing in 1 in place of the x, we get 6 multiplied by 1 plus 6, which is positive 12. So if we end up getting a negative, so a number that's less than 0, we actually have a maximum turning point. And if we get a positive, we end up getting a minimum turning point. So minus 12 is the maximum turning point, and positive 12 is the minimum turning point. So now we know which is which. So step 3, substitute the x values into the original equation. So that's the equation that we're given at the top, the function at the top. So our x values are minus 3 and 1, and now we know which is the maximum and which is the minimum. So the minus 3 value represents the maximum. So we have a maximum at x equals minus 3. So we sub in minus 3 into our function. So swapping the x for minus 3, we get minus 3 cubed. Then swapping the next x, we get 3 multiplied by minus 3 squared. Then swapping that x, we get minus 3 by minus 9. And then just bring down the plus 5. And this ends up giving us 32. So we have a local maximum turning point at minus 3, 32. So an x value of minus 3 and a y value of 32. So a local maximum turning point at minus 3, 32. We do the same thing when x is equal to 1, subbing it into the original function. So f of 1 is going to be 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5, which gives us 0. So we have an x value of 1 and a y value of 0. So we have a local minimum turning point at 1, 0. So an x value of 1 and a y value of 0 gives us a local minimum turning point at 1, 0. So we know that minus 332 is a local maximum because when we subbed minus 3 into the second derivative, we got minus 12, which is less than 0. So we got a negative value. So we know it's a maximum. And likewise, we know that the point 1, 0 is the local minimum turning point because when we subbed x is equal to 1 into the second derivative, we got 12, which is a positive. It's greater than 0, so it's a minimum. Hence, sketch the graph of the function f on the axis below. So hence means using what you've already found. So we have to use the maximum and minimum turning points that we've already found, and also our coordinates that cross the x and y axis. So we found the point at which our graph cuts the y axis. to be 0, 5. So we go to 0 on the x-axis, 5 on the y-axis, and we plot our point. That's that red dot there. We found the point that cuts the x-axis to be minus 5, 0. So we go to minus 5 on the x-axis, 0 on the y-axis, and we plot our point. We found our maximum turning point to be minus 3, 32. So go to minus 3 on the x-axis, 32 on the y-axis. And we found our minimum turning point to be 1, 0. So we go to 1 on our x-axis, 0 on our y-axis, plot our point. And then we join them together in a curve, making sure that it represents an S shape, because we have a quadratic function, which is an x cubed function. So we know that we're going to have an S shape, which we do.